Good evening, students. Hope my voice is audible to all. Anyone, please respond.
Yes, sir, audible.
Yeah, fine, Deepa. Thank you very much. So, guys, hope you are all working good, and I think you are working on FSMs right now. So, hope you all completed the assignments. And today we are going to learn industrial oriented thing, but the understanding you can get through this mini project. So today we are going to discuss about the vending machines which are used in daily life as well as increasing which are linking to the QR codes and so many network related operations in our daily life. So we are going to learn. So let me start the session today. Let me present my screen. Guys, hope my screen is visible to all. Fine. Today we are going to discuss about vending machine. So it is actually a mini project on Verilog you are going to work. So we are going to provide a basic information about that, what and all the states we are going to cover, and based on that you are going to work on the FSM part. So today this is actually a Murray type. It just depends upon the states. Whenever it reaches the state, like whatever the state we want, it should go like it should throw the output as well. So that's we are going to discuss. See, this is the daily vending machines we are going to see in the daily day-to-day life, like in malls or sometimes on the streets. In foreign, every street has some this vending machines there. So what are the inputs? So there are so many type of items we are going to select here. So if we want to select this bottle, we will enter this number. First of all, a secured number will be provided for this. So we'll just enter this number and then we will give our input. So input is nothing but what? The money through the coins or through the QR code nowadays. Then based on that, we're getting the outputs from this box. So let me, okay, fine. So this is the part of where we give the inputs and this is the part where we get the output. So this is the day-to-day life vending machine. So what's actually behind the vending machine? The FSM logic, which we are going to discuss as a basic thing. So this is the very big vending machine. It has more than nearly 50 to 60 items. But in this FSM, we are going to discuss just 4 to 5 states with respect to the inputs. Just small, very small coins also like. So let's see. So the project purpose is mainly based on the vending machine. So here we have totally, there are 3 coins we have. One is 25 rupees coin, 25 pies, 50 pies and 1 rupee coin. So these are only the inputs we have. Based on that, we are getting whenever it reaches 100 pies. So whenever the value reaches 100 pies, the output is going to high. So this is the basic FSM we are going to design. See, so why FSM? So why we are going to do only this vending machine with FSM? Generally, right? So FSMs are actually based on what? So it stores the memory, and based on the storing memory, it will use it to analyze that one, and based on that memory, it is going to predict the next value based on our inputs. So this is the basic functionality of FSM. So that is going to be functionality. That functionality is going to be like implemented in our vending machine. So FSM stores the accumulated values in the states. So you know what? The states are stored in the values. They are actually stores the values. So this allows correction detection, like correct detection whenever the amount reaches 100 pies. So 100 pies or 1 rupee, whatever it may be. So whenever in total, whenever the overall input reaches to 100 pies, our FSM going to throw the output. Let's throw like getting anything like so data out should be out. See, these are the inputs we are actually giving. So there are 2 types you have to keep in mind. So one is input and another one is state. See, so these are the inputs we have. So we have only 25 pice coin, 50 pice coin, 1 rupee coin and no coin. So based on that, we have so many states. We can design our own state. Like one pice state, we can decide like, so 25 pice we can decide, 50 pice we can decide, 75 pice. What are the combinations of states comes with this coin, we will design that states. So we have to cover the corner cases, right? So that many states we will design. These are the inputs we have. So for 25 pi is 0, 0 and no coin 1, 1. These are the states we have. So since they are 2 bit, so we are declaring it as 1 down to 0. The coin in as 1 down to 0. And we are using the system clock with like use any frequency you want. No problem. And this is the output. So we are declaring the output of our FSM as data out and that should go high whenever it reaches 100 pies. So when in total, how many values? The overall value is 100 pies. The data out going to be high. This is a Moore FSM because it depends only on the state, not the present inputs like that. And see, so these are the FSM state. As I said before, with the coins, what are the coins we have? How many states we will get? In total, we'll get this many states. So one is of 0, 0, which is no, like it's the initial state. It's a 25 pi state, 50 pi state, 75 pi state, and 100 pies. So 100 pies is nothing 1 rupee. Like these many states we have. So these are the FSM states we have. Those are the inputs. As I said before, those are the inputs. And this is the state encoding. So how many states we have? Totally 5 states. So we are declaring each state as this, like this. So this many states requires 3 bits of values. You can declare the states as reg 3 down 2 down to 0, and you have this states and all. And the initial output is initial reset. So first of all, what we have to do? Every FSM or every sequential logic should begin with a reset. The reset is very important. So that only makes the state to come to the initial state again. So this means that machine has collected 0 pies, like nothing collected. That state is known as 0 pi state. See, these are the transition. So whenever we are in that state 0, 0 state, whenever if you give the input as 25 pies, it should go to the 25 pi state. And whenever if you are in 0, 0 state, again if you go, again if you give the 50 pies as input, it should go to 50 pi state. If you directly give the input 1, automatically it should go directly to the 100 pi state, and our data out should be high. So nothing if you give means state 0, 0 only, it will be stayed. So like this transition from 0, 0 to this many states we have to go through. Again, this is the 25 pi state. Right now we are in 25 pi state. So we give the input as 25, it goes to 50. So 25 plus 25 what? 50. 50 state it should go. Again, 25 plus 50, it should go to 75. Again, 25 plus 1 rupee. It's one in total one value is 125. 5. So, but our FSM is stayed at 100 pies only, because whenever if you get the minimum value is 100, whatever the maximum, like if you give the 150 also, it should be in the state 100 only, we'll get the output. And we are not in this FSM, we are not receiving the balance, like if you're not receiving the money back, whenever it reaches 100 or more than that, you will get the output as high. That's it. And this is the 55 state. If you give this many inputs, these are the states we will achieve. Like this state transitions are there. And this is 75 pi state. So right now we are in 100 pies. Like 100 pies is nothing 1 rupee state. So that out go should just go like that should go high. Machine reset to state 0, 0 again. So right now we are in what state? State 100, 100. So if you give whatever the input you give again, that should go to again reset state, because you received the output, right? So you received some biscuit packet or what, then again it should go to what? Reset. Like that we have to go keep on the FSM going to be worked. So these are the FSM consists of what? As I said before, state registers, next state logic, and output logic. These are the three always block we have to write. We have to going to be implemented. So this is the minimum. This is the like for your reference. I am providing the state register code. So this is the we are triggering it as positive edge, and you can use positive edge of reset or negative reset. It's your wish. And here the state. So this is sequential logic we are going to be writing, and this is the combination logic. So right now, just I am giving for state 0, 0. You can implement another states also. So this is the combination logic, and this is the output logic, main logic. So and here see. So these are the coins inserted. So how many types of coins we are using? 25 to 25, again 50. Like this we are going to be inserted. How many coins you can insert? So that can have a sequence. You can try so many combinations. There are nearly like 10, more than 10 to 15 combinations we can try to achieve the 100 pies state. So this is the done out becomes 1 whenever it reaches to 100 pies. So see, this is the FSM we are going to be design. So based on this FSM, try to implement the Verilog code. So right now we are in what? Reset state. So this is the reset state. So it's actually 0 pies. So see, if I give 0 pies, like 25 pies, it's going to the 25 pi state. And again, 50 pies, going to the 50 pies. And again, if you give the input as 1 rupee, directly goes to the 100 pi state. So there is no 75 rupees kind here. So it won't go to that state. So it is actually a mediate state with these combinations. See, right now again we are like this next state logic is completed. Again, right now we are in 25 pies. So what are the different combinations we have? We can give 25 pies, we can give 50 pies, and we can give 1 rupee directly. So that transitions are going to be like this. So 25 to again what? If you give 1 rupee directly, it goes to the 125 actually. So No need of change. There is no change state here. Just 100 pies you can directly go. And again, if you give 25 to 25, again it reaches 50. So 25 plus 25, 50. And again, 25 plus 1 rupee, like 25 plus 50 again, 75. So this is the intermediate state we are going to be taking for additional support. So like that, this is the FSM we are going to design the Verilog code. Take this FSM as a reference and try to implement Verilog code. And see, so these are the main applications of vending machines in your day-to-day lives. So ticket vending machine. So you know how right? Ticket collectors. So right now we are working in digital ecosystem. So we have so many type of areas we want to go. So how that actually happening? So through FSMs only. And snacks vending machine, as I said before, as I discussed before, and ATM payment systems. So whenever you have the banking systems also using this type of FSMs, and parking ticket machines. These are the four. There are so many like applications. These are major we are seeing now day to day lives. So this is a project summary. So we are going to end up this session. So there's actually vending machines are implemented using Moore type. So here actually it's based only on the state. That's why we are going to have this one. And again, see how many states we have. Totally five states. Just five states. So done out is accepted. Whenever it reaches accepted is nothing but what? Just going to high like that. So whenever it reaches 100 pies, the done out should be high. So like this, we are going to design. So implement this FSM. You can have you can take 2 to 3 days, no problem. And after that, we can have a debugging session. So implement the RTL code, then go to the test bench. Try to give as many as the inputs. So try to verify this FSM with as many as the inputs in the test bench. So you can verify, you can give like 20 to 30 inputs. So every state, try to cover every state and every transition. That's the project, that's the task given for you. So you have to cover every transitions. There are totally five states with so many combinations, right? So every transition you have to cover through your TB and analyze the waveforms. So where this in like the on this mini project, actually we are trying to keep the reviews also like that. So let me wind up session and so just take a screenshot of this FSM. So let me enlarge this one. Yeah, guys, try to take the screenshot of this FSM. Yeah, fine. So hope you all take the screenshot of this FSM. So actually what we are planning is, so we have to try to cover the Verilog code within 2 to 3 days. And after that, so just post your timing analysis reports. No need of reports and waveforms, just waveforms, your Verilog code, your RTL code, test bench, and then waveforms. So no need of drawing FSM since we provided FSM, no need of drawing any FSM. So just three things we want. So first one is RTL code, second thing is test bench, and then waveforms related for this. If you are like you have to simulate it and you have to share the screenshot of the waveform. So make it a PDF and try to upload like 4 to 5 days. If you have any doubts related to transitions, if you have any doubts, after 3 days we will meet. I will keep a doubt solving session for this. Yeah, I will keep a doubt solving session after 3 days. We will discuss other inputs, how many corner cases we can cover. So after 3 days, we have doubt session, and totally within 6 days you have to complete this project. After 6 days, we have a presentation on this. So we have a set of students, like total 33 are there, right? So for 10 members, we are going to plan PPT presentation on this project for 3 days. So this is just for testing your communication skills and as well as your presentation skills. So by the end of 6 days, like after 6 days, we have a presentation on this project. So try to complete like that. So this is the task provided for you. That's it, students. Up to today. So if you have any doubts related for this building of this FSM, you can ask. So meanwhile, work on the assignments also. I think deadline has completed. So no need like at least try to solve the assignments and start implementing this mini project. After 6 days, we will intimate you, like we will plan the PPTs, we will give the names and the dates of the students on presentations. So that will be updated in the group. So anyone have the doubts? Let me know, please. Yeah, you can free to ask. So you should like everyone has to submit this mini project. So this is like basic project you have to submit along with your source code. So I need code of RTL Verilog and TB and waveforms output, and that's it. These three. After getting all your PDFs, we are going to plan the presentations after 6 days. So this is the thing. Like hope you guys have done like most of you are understand this problem. So thank you guys. Thank you for joining today meet. Thank you very much.